Alright guys, so I welcome you to another tutorial. In this tutorial we will dwell much on demonstrating how to use while conditional statement in Arduino IDE using C++, and the condition statement that you'll be using are while statements, and we'll try to calibrate a sensor. Then whilst we are doing that, we'll try to turn on the LED based on the sensor value, but in this time we'll not use if statement, but we are not going to use conditional statements like if else statement, but you're going to use while statement. And we are also going to introduce a button, a push button. So while a button is pressed, the sketch is going to run the calibration routine. Then the sensor reading during the while loop define the minimum and the maximum expected values for the photoresistor, because in this case what you're going to use is a photoresistor. And a photoresistor is a kind of a sensor that reads the light intensity in terms of candelas. Then it's understood as a voltage levels by an Arduino microcontroller. So how will the circuit look like? So your photoresistor will be connected from 5 volts to analog in pin 0, A0, because it's analog. Then you're going to have a 10 kilo ohm resistor connected from ground to analog pin A0. So you're going to connect your sensor through the ground via a 10 kilo ohm resistor. Then the indicator, which is going to be an LED, will be connected at pin 9 to ground through a 220 ohm resistor to act as current limiter and also an external pull-up. Then you're going to have a push button attached from pin 2 to 5 volts and a 10 kilo ohm resistor attached to pin 2. So in this case, you're going to run your 5 volts will run through the 10 kilo ohm resistor, then into the push button, then back to the ground. And this code was modified by me, and I should mention something, that most of the Arduino codes, Arduino is an open source, so most of these codes are there, or you get the idea somewhere, then you modify it. So this is just one of those ideas which I just got from somewhere. Some time back, when I was trying to do the calibration of the sensor I was working on. Okay, so now let's try and understand what's going on. So with this section here, we're just trying to, nothing is going to change in this section. All of these are just constants, because what the sensor pin you connect to A0 to remain like that. Then the LED pin 9 will always remain like that. Then the indicator pin 13 will always remain like that. And you know, in Arduino microcontrollers, specifically Arduino Uno, Arduino Nano, lead pin 13 is a built-in pin. Okay, and the attached pin, the built-in LED is attached to this pin. All right, so and then lead pin number 2 is where we're going to connect our push button. All right, so the variables that is going to be holding our values, and they're also going to be constants. So integer sensor mean value, the minimum sensor value will be 1023. I think here it's a mistake that was made. It's actually supposed to be the other way around, because if you look at 1023 is actually the maximum value, and if you look at the 0 is a minimum value. So this is a mistake which was made there. We can just easily correct that. I just made a mistake there. Then integer sensor value. So this is a variable that's going to be holding the values that is going to be passed on from the sensor here. So under the void setup, here you're going to put the code that can run only once, and you see that the indicator lead pin will be an output, the lead pin will be an output, the button push will be the input, or the push button pin will also be an input pin. Then under our void loop here is where you're going to put our while statement or a conditional statement, so that you see how you apply a while statement. So you see that while the button is pressed, the calibration will start taking the readings and the calibration will be underway. So we are going to say that while digital read button pin is high, calibrate. So what's happening is that you'll be reading from button pin, where we are going to get your sensor. Whenever you are collecting information from an input kind, you use the statement digital read, because you are collecting from, or you are reading from. So in this case, you are reading from the sensor, which is connected to button pin, in this case, which is pin 2. And for as long as this is high, it means that the sensor values are coming and the button was pressed, and this means that the calibration will begin. So while the button is pressed, then calibration will start happening. The signal, the end of the calibration period, what's going to happen is you're going to say digital write indicator lead pin low, because when this is taking place, lead pin 13 is going, this lead pin 13 is actually found on the Arduino Uno or the Arduino Nano microcontroller. So for as long as you have pressed the button, that pin is going to flash, and it will keep flashing. It will go on. Then when the calibration ends, the period of calibration ends, you're going to put this statement saying digital write indicator lead pin, which is on pin 13, should go low, so that light goes off, telling you that the calibration has finished. Then the read sensor. So you're going to say sensor value. In this manner, what you're actually doing is you're passing that values that are collected from the sensor pin, being read as analog read, then passed on to as an argument those values to sensor value there. Then now you want to apply your calibration. So this statement here is just the calibration statement. You say sensor value, which you have collected here, which the sensors read. Then you say map. Map is a function that helps you to calibrate. You say map sensor value, sensor mean, sensor max, and it should run between 0 to 255 in that range. In case the sensor value is outside the range, then seen during calibration, then you say that sensor value constrain sensor value just between. So here we are just trying to say that should it happen that we had an overflow, let's say 256, 257, this statement here is just trying to say restrict within 0 to 255. Then you're going to say analog write lead pin sensor value. Okay, so here what's happening is that you're just fading the LED using the calibrated value like that. Then under your same loop, you're going to have your void calibrate this function. You're going to turn on an LED to indicate that the calibration is happening. So you're going to say that digital write lead indicator lead pin high, which is the same pin 13. Then you read the sensor value. Say sensor value analog read sensor pin, which is basically the same as what we have somewhere here. It's actually the repetition of that. Then what's going to happen is that record the maximum sensor value by saying if sensor value is greater than the sensor max, begin sensor max is sensor value, like that. So you have now calibrated what is your maximum value in this case. If sensor value is less than sensor mean, then begin sensor mean is equals to the sensor value. So by saying these statements, you're actually calibrating your sensor now. So this is how you can use the while statement and the if statement as you calibrate your sensor. And as you are doing this, your lead You'll also be learning how to turn on and off your LEDs, which means this project you can even extend it to other means of, or to other real project that can solve problems by just first of all start calibrating the values of the sensor that we want. Then on these lead pins, like on lead pin 9, you can connect anything to that. Alright, so thank you guys. With this code, I was just basically trying to explain and show you how you can calibrate the sensor, and also how you can put the wow statement to use. Thank you so much, and I hope you put this project to good use. All right.